Okay, so I have graphed it on Desmos. Now keep in mind we have large numbers, so that's why my graph looks like this. So I'm going to zoom in to our x-intercepts because that's where our answer is. Oh my goodness, where did it go? Oh dear Jesus, there we go. All right, so zooming in, can I get both of them? Yes. All right, so we want these two values right here. So our x-intercept here, we can, let's round to thousandths place. So on your paper, we are going to write that the intercept is, I'm going to write it and then I'll show you, but we're going to say that it's approximately 45.969 thousandths. Okay, and L is also approximately 174.031 thousand. So what did I do? I just, oh, why is it not? Okay, there we go. It was still stuck from the previous video. So this is where I wrote those values from our Desmos. Okay. Go back to the Desmos. There we go. All right, so the solution consists of the values for which the graph lies on above the axis, the graph lies on or above it between those two numbers. All right, so let's round whole numbers. So what I'm saying is we can't have negatives, so it's just in between these two numbers up here. So we're basically going to say it's in between. The area can be any numbers in between 46 and 174 feet. So anything in between that would work. But that's your links. All right, so let's see. Let's come back to here so we can write that down. All right, so we're going to say, so the approximate heights of the region are at least 46 feet and at most 174 feet. I'm going to add that and come back. All right, so voila, it's written. So the approximate lengths of the region are at least 46 feet and at most 174 feet. They love doing perimeter and area with these questions. So if you have another one on your practice, it will probably be very similar. I do not have a self-assessment question for this one. They did not give me one. So we are just going to move on to example 4. All right, so example 4. We are now graphing systems of inequality. So before we did just one of these, right? So now we're going to do both. Remember, we're still going to shade, but the solution would be where the shading overlaps. So you really do need two different color pencils, or when you overlap your shading, just make that section a lot darker than the other two. Okay, so let's get started. I don't know what that is. Okay, so we're going to graph each equation. So we have negative x squared plus 4. So if we have negative x squared plus 4, we know our vertex and our y-intercept are the same thing. This tells me my graph faces down. I'm going to plot with a pencil. All right, so 1, 2, 3, 4. That is my vertex right there. We know it faces down. I need some more points. All right, so let's see. Let's pick a number close. I don't want to go 1. Let's go 2. So when x is 2, what is y? So we're just going to do it as it equals for this part. So 2 squared gives us 4. So we have negative 4 plus 4. So when x is 2, y is 0. So that gives me one of the x-intercepts right here. All right, now remember, because of axis of symmetry, I know there's another point right there. So if you want more, you can. Like if you want to try 3 or 4, go for it. All right, so now looking back, this tells us that our line should be a dashed line. So I'm going to now connect my dots using a dashed line. All right, what part would be shaded? So remember, I told you we can go with the values above because it says x is greater than. So I would assume that would be the values above. I said x. Why? One day I'll get my life together. So y is greater than. So we're assuming it's these. So how can we tell for sure? We could plug in the origin. If we plug in 0 for both of these, it should be a false statement. So that would tell us that our prediction is correct. So let's plug in 0 for each one of these. So if we had 0 squared, it's just going to be 0. 0 plus 4. Is 0 greater than 4? No. So that means that we were correct with our prediction. So we are going to shade everything that is above or outside of the parabola. Not necessarily above, but outside of the parabola. All right, so we're shading all of that. So there's our one graph. All right, our next one is a nice linear one. Those are fun to graph because we just do y equals mx plus b. So what is my b? It is 2, so I'm going to have a 2 right here. And then my slope is 1, so I'm going to go up 1 over 1. So basically, it goes through the corners of all the boxes. Now this one also is not equal to, so it is a dashed line. So we're just going to make this a dashed line going through the corner of the boxes forever until the end of the graph. La, 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 la. All right. So now, again, we have y is greater than, so I'm going to assume it's the values of y that are positive, but we can try 0, 0 again and see if it's a true statement. So if we plugged in 0 for y, 0 for x, we would have 0 plus 2. Is 0 greater than 2? If you said no, you are correct, because 0 is not greater than 2. So here's where I'm going to take my other color, go with orange, and I'm going to shade everything above this line. All right, so that's what makes that a true statement. Now, only the things that I shaded twice, so only this green and orange part together are the actual solution. So this orange part in here is not part of the solution. Only these that were shaded together. All right, so our solution would be this area here. So any ordered pair in that section of shaded graph would be a true statement. All right, so that would be the answer to this. That would be your solution. All right, so when we're doing these, you're going to find graphs, and you're looking most of the time on like Big Ideas. They have this as like the darker part. Okay. So we're going to do one more together before I have you try one on your own. If you want to go ahead and try this one on your own, and it's up to you. Okay, so we have two parabolas this time. We know this one's facing down, this one's facing up, just based on this part. We know this one has a y-intercept of +3, this one has a y-intercept of -3, and this one, the vertex, is the y-intercept because there's no b value. So let's start there. So we know this is our vertex, we know it's facing down. We need another point. So let's go with 2. All right, let's find out with 2. So what does y equal when I substitute in 2 for x? So 2 squared gives me 4, so I have -4 plus 3, so y is equal to -1. Oh, sorry, I didn't realize I was off the screen there. So when I substitute in 2, I get -1. So 2, -1. So axisymmetry tells us there's another one right there. Now, this one I have a dashed line, so I'm going to draw my lines. Now, it does say y is less than, so I'm going to assume that we're shading this area. Again, we can, this is my favorite point to test because it's so easy that you can just go up here. Is 0 less than 0 plus 3? So is 0 less than 3? Yes, so we're definitely shading this area here. So for this parabola, we get this part shaded. I know y'all love watching me color. It's so satisfying, right? Just kidding. I don't know. Maybe you do, maybe you don't. All right, we're graphing this one. So we got a -3 as our y-intercept. So this time it is not our vertex. It's just our y-intercept. How do we find the vertex? If you said to use this formula, then you are correct. So we're going to substitute that in. -2 over 2 times 1 gives us -2 over 2, which equals -1. So our vertex is -1 comma something. So how do we find that something? We plug in the -1. So we have -1 squared plus 2 times -1 minus 3. So our vertex is -1, -4. Now this graph faces up. So -1, 1, 2, 3, 4. So right here. So now because of this point, or y, we know there's another one right here. And in this situation, it is or equal to, so my graph is going to be a solid line. And it does say y is greater, so again, we could test 0, 0 in here. Is 0 greater than or equal to 0 plus 0 minus 3? So is 0 greater than -3? Yes. So we would shade above. So again, it's telling you based on the inequality that y is greater, so it's the y values above. But if you ever second guess yourself, you're unsure, you can always test that point to be 100% sure. Okay, so now where's our solution? This part right here where it overlapped, that is our solution.
Lane.
All right, so here are your 2 to try. I did give you graphs on four graphs on that thing. So if you should be using that. I didn't think about it when I made this, so I'm going to be using that as well. All right, so pause the video, give these a try. All right, so here's the first one from there. Hopefully you weren't too scared of the fractions. You can always put your fractions in the calculator. I know you don't all have this calculator with you, but you do have access to calculators with fractions. You could always put it, you could turn them into decimals as well. All right, so that's fine too. Okay, so I got the vertex is -3/2, -1/4 for this one. So our solution is right here where they overlap. So if you have questions on this one, please ask in class. Now I'm going to do this one and come back. So if you didn't try that one yet, please pause your screen and do it now. All right, so here's the last one. This one's a little weird just because normally they do them facing the opposite direction or something like that. So our solution would be just this part right here. So not this part where the orange, just orange, or not this part where just green. It would be right in here. So if you're curious, I found for the first one, the vertex was -1, -2, which is my orange shaded graph. And then I found -1, -3 for the vertex for my green shaded graph. So like always, if you have questions on these, please ask in class. I know graphing isn't a lot of people's strong suit, but it is something that isn't going away. So if you have questions, please ask. All right, I will see you in class.